Chapter 3-1. What you will learn. First, you will learn how to identify parallel, perpendicular, and skewed lines. Then, you will learn how to identify the angles formed by two lines and a transversal. Our first section is on lines. There are four types of lines and planes that you need to know. Our first type of line is a parallel line. Parallel lines are coplanar and do not intersect. On our diagram, parallel lines will look something like this. Line EA is parallel to line FB. Our second type of line is a perpendicular line. Perpendicular lines intersect at 90-degree angles. On our diagram, a perpendicular line looks something like this. AE is perpendicular to line EF. These are perpendicular lines. Skewed lines are not coplanar, they are not parallel, and they do not intersect. On our diagram, skewed lines look something like this. AB is skewed to line EG. This is a skewed line. The last thing is parallel planes. These are planes that do not intersect. On our diagram, parallel planes look like this. Plane EAB is parallel to plane GC and D. These are parallel planes. Next, we will do 3 problems to help you understand what some of these lines are. Number 1, a pair of parallel segments. On our diagram, a pair of parallel segments will look something like this. Segment CG is going to be parallel to segment DH. Number 2, a pair of skewed segments. On the diagram I have drawn out, a pair of skewed segments is going to look something like this. Segment CD is going to be skewed to segment BF. Number 3, a pair of parallel planes. On the diagram drawn out, a pair of parallel planes will look something like this. Plane B, C, and D will be parallel to plane F, G, and H. Next, we will go on to learn about angles. Before we talk about any types of angles, we need to know what a transversal is. A transversal is a line that intersects two coplanar lines at 2 different points. So on my diagram, our transversal is this line right here, covered in red. This is a transversal. For the time being, our transversal is going to be noticed by the letter T. Now we can talk about the 4 types of angles we have. Our first one is a corresponding angle. Corresponding angles lie on the same side of the transversal, represented by T, and on the same side of lines R and S. So on our diagram, corresponding angles will be angle 1 and angle 5. They lie on the left side of our transversal T, but on top of lines S and R. Next, we have alternate interior angles. These are non-adjacent angles that lie on opposite sides of the transversal represented by T and between lines R and S. On the diagram, alternate interior angles are going to be angle 3 and angle 6. They lie on opposite sides of the transversal, but they lie on the inside of both lines R and S. Next, we have alternate exterior angles. Alternate exterior angles lie on opposite sides of the transversal T and outside lines R and S. On our diagram, alternate exterior angles are going to be angles 1 and 8. They lie on opposite sides of the transversal, but on the outside of lines R and S. Our last type of angle is same-side interior angles, and they're also known as consecutive interior angles. These lie on the same side of the transversal, represented by T, and between lines R and S. On the diagram, same-side interior angles are going to be angles 3 and angles 5. They lie on the same side of the transversal and between lines R and S. Now, we will do 4 problems to help you learn what each of these angles are. Number 1, corresponding angles. On the new diagram drawn out, corresponding angles will be angles 5 and angles 7. Number 2, alternate interior angles. Alternate interior angles on this diagram are going to be 6 and 3. Alternate exterior angles. On this diagram, alternate exterior angles are going to be angles 1 and angle 8. Number 4, same side interior angles. Same side interior angles on this diagram will be angles 2 and angles 3. So now, let's work through 4 problems to help you understand both lines and angles. Number 1, on the diagram shown to the right, we're going to show a pair of parallel segments. A pair of parallel segments will look like this. Segment AB, a pair of parallel segments will look like this. Segment AB and segment DC. Number 2, a pair of perpendicular segments. A pair of perpendicular segments on the diagram to the right will look like this. Segment EF and segment FG. Now we're going to go on to the angles section. For number 3, we're going to identify what angles 2 and 3 are. On the diagram to the left, you will see angles 2 and 3 circled in red. These 2 angles are alternate exterior angles. Number 4, we are going to identify angles 4 and 5. Angles 4 and 5 are going to be circled in blue. These are same side interior angles. Now you know how to identify parallel, perpendicular, and skewed lines, as well as how to identify the angles formed by 2 lines and a transversal.
Lesson 3-2. If 2 parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. Here's an example. We can see that 1 and 6 and 3 and 8 are all congruent, and 5 and 2 and 7 and 4 are all congruent. The corresponding angles postulate. If we want to find the measure of angle ABC, we know that x must equal 80 according to the corresponding angles postulate. Next, if we want to find the measure of angle DEF, we know we have to set it up as 2x minus 45 equals x plus 30, according to the corresponding angles postulate. Next, we subtract x from both sides, then we add 45 to both sides, then we substitute 75 for x, and should end up with 75 plus 30, which equals 105 degrees. Here are some theorems of parallel lines and angle pairs. The alternate interior angles theorem states that if 2 parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent, such as angle 1 and angle 3, and angle 2 and angle 4. The alternate exterior angles theorem states that if 2 parallel lines are cut by a transversal, then the two pairs of alternate exterior angles are congruent, such as angle 5 and angle 7, and angle 6 and angle 8. The same side interior angles theorem states that if two parallel lines are cut by a transversal, then the two pairs of same side interior angles are supplementary, such as the measurement of angle 1 plus the measurement of angle 4 should equal 180 degrees, and if the measurement of angle 2 and the measurement of angle 3 should equal 180 degrees. Here's the alternate interior angles theorem shown with a proof. Our given is that L and M are congruent. Next we see that angle 1 and angle 3 are congruent according to the corresponding angles postulate. Then we see that angle 2 and angle 1 are congruent according to the vertical angles theorem. This all goes to show that angle 2 and angle 3 are congruent according to the transitive property of congruency. Moving on to finding some angle measures. In A, we see that we need to find the measurement of angle D and DEF. We know that x 125 degrees because of the alternate exterior angles theorem, because x and 125 are alternate exterior angles. In part B, we want to find the measurement of angle TUS. 13x plus 23x equals 180, according to the same side interior angles theorem. Then we combine like terms and end up with 36x equals 180. Then we divide both sides by 36 and end up with x equals 5. The measurement of angle TUS equals 23 times 5, which should equal 115 degrees when we substitute 5 for x. Here are some practice problems. We need to find the measurement of angle KLM. We know that KLM equals y. We know that y equals 115 degrees according to the corresponding angles postulate. Next, we want to find the measurement of angle STU. We know that we have to set it up as 4x minus 14 degrees equals 3x plus 12. We know that we subtract 3x from both sides and end up with x minus 14 equals 12. Then we add 14 to both sides and should get x equals 26. We substitute 26 in for x, and then we end up with 104 minus 14 equals 90 degrees. We substitute 26 for x one more time, and we should get 78 plus 12 equals 190. We can confirm that the measurement of angle STU equals 90 degrees. Now we'll be finding some angle measurements. The measurement of angle 1 equals 120 degrees according to the corresponding angles postulate. The measurement of angle 3 equals 60 degrees due to the same side interior angles theorem. The measurement of angle 5 equals 60 degrees according to the linear pair theorem.
So welcome to Geometry 3-3 review. This is could be the first part. The postulate says if two coplanar lines are cut by a transversal so that a pair of corresponding angles are congruent, and then the two lines are parallel. Yeah. So our two coplanar lines are L and M, and we are trying to prove them parallel. And then we have our transversal here, which is cutting between both of them. And this creates two corresponding angles that are congruent, which means they equal each other. So since we read this again, if two coplanar lines are cut by a transversal so that a pair of corresponding angles are congruent, so they become created, then the two lines are parallel. So we just proved that M and N are parallel to each other using converse of corresponding angles postulate. So we're going to work on one here. We're going to be proving L and M. So let's use 1 and 5. So angle 1 to 5. Okay. So this is one of our complementary lines. These are our two lines. And then we have our transversal that cuts between it, creates both corresponding angles, which proves, since these corresponding angles are congruent to each other, so they automatically make the two parallel lines parallel to each other. So we're going to put parallel to M using converse of corresponding angles postulate. Okay, now we're going to do the second part of it. So we're going to be plugging in number 13, or X, which is 13, into here, to these measurements. So again, we have our two lines and our transversal, and so it gave us 7 and 5. So here will be our corresponding angles, these two. And so we already know, since they're corresponding angles, they're congruent, but they gave us a problem here where we have to plug 13 into 4x and 15. So let's write for measurement of angle 7 equal to 4 times 13 plus 25. And then we have measurement 5 equals to 5 times 13 plus 12. Okay, so let's do this one first. This 5 times 13 equals 65 plus 12 equals 7. So measuring 77, sorry, 77 degrees. And then we do 4 times 13, which is 52 plus 25 equals to 77. So since they're both equal to each other, they're congruent. So we just proved using definition of angles, M, or angles 5 is congruent to angles 7, and then we do L is parallel to M. This is using definition of angles, and this is converse of corresponding angles. Postulate or theorem. So yeah, that's the first part. Okay, so in this part, we're going to be using 3 theorems: converse of alternate interior angles theorem, converse of alternate exterior angles theorem, and converse of same side angles theorem. So, converse of alternate interior angles. It has the word alternate and interior. Alternate means different, like different sides. And then interior means on the inside. So on the inside of these two complementary lines. Okay, so if two complementary lines are cut by a transversal so that a pair of alternate interior angles are congruent, then two lines are parallel. So that means that if a pair of alternate interior angles are congruent, so they're alternate, they're interior, and they're congruent, and the two lines are parallel. So having these two proves that these two lines are parallel to each other using converse of alternate interior angles theorem. Okay, so the next one is converse of alternate exterior angles. Pretty much the same thing, but we're going to be doing exterior, which means the angles are going to be on the outside. This is the exterior. So if two complementary lines are cut by a transversal so that a pair of alternate exterior angles are congruent, then the two lines are parallel. So these are our two alternate exterior angles. They are congruent, which proves that these two complementary lines are parallel to each other. Same here, using converse of alternate exterior angles theorem. And then lastly, we have converse of same side interior angles theorem. So this is basically saying that they're on the interior and they're on the same side. So here. So if two complementary lines are cut by a transversal so that a pair of same side interior angles are supplementary, then two lines are parallel. Supplementary means that they are immediately equal to 180. So these two angles equal to 180. So same side cut by transversal makes these two angles right there, and it proves that M and N are parallel to each other using converse of same side interior angles theorem. So let's try all of them. We do converse of alternate interior angles theorem first. We gotta do 3 and 6. So angle 3 is congruent to angle 6. And then here's our two lines here, transversal angles. They're congruent to each other. And so since they're congruent, then the two lines are parallel. So is parallel to M using converse of alternate interior angles theorem. So that's the first one. The next one would be converse of alternate exterior angles. So we can use 1 and 8. They're congruent to each other, so angle 1 and angle 8 congruent to each other. So two complementary lines are cut by a transversal so that a pair of alternate exterior angles are congruent, and the two lines are parallel. So here's our two complementary lines. So right here is our transversal line. Creates these two angles here that are congruent to each other. That proves that our two lines are parallel. So parallel to M using converse of alternate exterior angles theorem. Alright, so lastly we have our converse of same side interior angles theorem. So for this one, you can go 4 and 6. 4 is, angle 4 plus, or measurement of angle 4 plus measurement of angle 6 are equal to 180. Since they're supplementary, then means our two complementary lines. So I have two complementary lines are cut by a transversal so that the pair of the same side angles, same side interior angles are supplementary, which means that they equal 180, and the two lines are parallel. So L parallel to M using converse of same side interior angles. Okay, now we can do this one too. So we have measurement of angle 6 equals 6x plus 18 degree sign. So x equals 10, so 6 times 10 is 60 plus 18, 78. Now we have measurement of angle 7 equals 9x plus 12. So 9 times 10 equals, just put 10 here. So 9 times 10 is 90 plus 12, 102. And so now you do measurement angle 6 plus measurement of angle 7 equals 78 plus 102, which equal 180. So measurement of angle 6 plus measurement of angle 7 equal 180. And since that it becomes 180, so it means there is supplementary. So the pair of same side interior angles are supplementary, and the two lines are parallel. So we'll just use line L is parallel to line M using converse of same side interior angles. Alright.
Good morning, guys. Today we're talking about the lesson 3, perpendicular line. So we should know what is the perpendicular line first, and what is the perpendicular line. Look at that. The line just like that. That is perpendicular line. Why? Because they're 90 degree in there. Because they're 90 degree in there. They're 90 degree in there. Same to there. So this one have the perpendicular line. So it's pretty easy, right? So we're just going to solve the really simple question now. Like, it's really simple. Let's go. When I draw the picture like that, So that's 90 degree in there because they have a figure and 6 x plus 2 in there and p in there, a, b, c for each point. So if we want to solve the question, what is x in this question? So what are we gonna do now? First, we need to name the shortest segment from P to line AC. That means the short distance from a point to a line is the length of the perpendicular segment. Line PB is the segment from P to line AC. Line PB is the segment from P to AC. What does that mean? That means this one is 90 degree too. Cause what? Cause we named the shortest segment is the first step. So what are we gonna do now? The B is so x now. So we can use the simple equation. PA is bigger than PB. So that means x plus 2 is bigger than 6. X is bigger than 4. So that's really simple, right? That's really easy. And what is the next question? After we know what is perpendicular line, we gotta know. I would told you 3 theorems in this lesson. First one is like so that means that A is perpendicular with M. Because if two intersecting line for a linear point of congruent angles, then the line's perpendicular. So that's what I'm talking about. It's the option 1. So the option 2 is like the 2 line was parallel and have a 90 degree in this angle. So what is that? A perpendicular with P. Because what? Because in a plane, if a transversal is perpendicular to one of 2 parallel lines, then it is perpendicular to other line. It is option 2. So next is gonna be option 3. If 2 coplanar lines are perpendicular to the same line, then the lines are parallel to each other. So that means this line is parallel to this line. It's parallel. R was parallel to S. So it's the 3 option and 3 important point in this lesson. So it's what are we gonna learn about it, and It's really, really important. So we should know what are we writing in there. What is that? We should remember that and use that to solve the question. And we're gonna solve the question now. Look at that. Let me write it now. If I set the question like that, if I say a question like that, how can I solve the question? How can I solve the x and y in this question? Okay, I know you're not good at this question. You can't understand. Okay, so I will teach you guys now. First, what we need to do now, we need solve the x first. So we know these two lines are parallel. So 2x is what's equal 90 degree. Why? Because we know this one. It must be 180 degree. So it's 90 degree in there. So 2x is equal 90 degree. X is equal 45 degree. So we know x is equal 45 degree. If we know x is equal 45 degrees, so we just like take into the equations like 2 multiplied by 45. What is the answer? It's like -90 degree. So the 90 degree the equation is like 3y minus 90 degree is equal 90 degree. Because what? Because they're parallel. If we know the lines in there is equal 90 degree, that means this one is 90 degree too. That is absolutely simple. We must know that. That is really, really simple question. Everybody should know that. So it's 3y is equal 180 now, and y is equal 60 degree. So this question, x is equal 45 degree, y is equal 60 degree in there. That's what I'm talking about. That is really simple question. We all should know that. We all must know that. Because that is really, really, really simple question. Okay, move next. For number 5 question. We thought of things like that. It's 6y in there, and it's 5x plus 4y in there. They're parallel. That's really easy. So we all should just find the 6y first. Why? Because 6y is equal 90 degree first. I told you guys if the 90 degree in there, so the 6y it must be 90 degree because the angles in there it must be 180 degree. So y was equal to 50 degree. And if we got y is equal 50 degree, what are we gonna do now is put into the equation 4 times 15 60 degree. 5x plus 6 degree is equal 90 degree. Just like for 5x is equal 30 degree and x is equal 6. So the answer is gonna be y is equal 15 degree, x is equal 6 degree. That's a really simple question, right? But you should know that. Okay, let us take a difficult question now. It's a hard question now. What is the hard question? We should find the details in the question and write the statement and reason in the question. So that is a little hard for you guys, but you should know that because I'm Dr. Henry. I teach you guys. That is you must to know. And that is the only things for you to know is to find the detail. Okay, let me write question now. If you say the plane like that, what are we gonna do now? What are we gonna do now? Look at that. So what do we know in this question? Given line 80 is parallel to line BC, line 80 is perpendicular with the line AB, line BC is perpendicular with line DC, so the proof is line AB is parallel to line DC. Okay, let's write it now. The left is statement. The right is reason. What is the first statement? We know line AD is parallel to line BC. We know line BC is perpendicular to line DC. So what does that mean? That is given. So we just write given, it's okay. And what do we know now? What can we prove now? Line AD is perpendicular with line DC. So what does that mean? That is perpendicular transfer theorem. So what is next? Line AD was perpendicular to line AB. What is that? That is given. Save our question. That is given. So what is the first step? It was line AB perpendicular to line DC. It is two line, two same line. Two lines parallel. So thank you guys for listening. I'm Henry.
Lesson 3-5. What you will learn. First, you will learn how to find the slope of a line. Then, you will use slopes to identify parallel and perpendicular lines. Before we get started on equations, there are some vocab that you need to know. First is the rise. The rise is the difference in the y values of 2 points on a line. In our diagram, the rise is represented in a blue color. These are your y values. Next, you need to know the run. Run is the difference in the x values of 2 points on a line. The run is in the color green on our diagram, and it has the x values. Last, you need to know what the slope of a line is. The slope of a line is the ratio of rise to run. If x1, y1, and x2, y2 are any 2 points on a line, the slope of the line is m equals y2 minus y1 over x2 minus x1. This equation is what we call the slope formula. And this is what we will be using for our equations later on. So let's learn how to find the slope of a line. First, we know that we need to use the slope formula. So let's write that out. Our slope formula is m equals y2 minus y1 over x2 minus x1. Now, we need to figure out where point G and H are on our graph. So point G is sitting at 0, 4, and point H is sitting at 3, negative 3. So now that we have our point, we're going to plug them into our slope formula. So m is going to equal negative 3 minus 4. This is your y2 and y1 over 3 minus 0. This is your x2 and x1. This is going to give us negative 7 over 3. So, line GH equals negative 7 over 3. This is how you find the slope of a line. So now that you know how to use the slope formula to find the slope, there are 4 different types of slopes that you will see. First is a positive slope. A positive slope is tilted to the right, as you can see drawn over in blue. Then we have a negative slope, which is tilted to the left. So it's the opposite of a positive slope. Then we have zero slope. Zero slope is parallel to the x-axis on a graph. And an undefined slope is parallel to the y-axis on a graph. These are the 4 types of slopes that you need to know. So now we're going to identify what kind of slopes these 2 problems are. So our first one, since it is tilted to the right, we have a positive slope. For our second one, since it is parallel to the x-axis, we have a 0 slope. So now that you know how to use slope formula and what types of slopes there are 2 theorems that you need to know. First, we have the parallel lines theorem. The parallel lines theorem says, in a coordinate plane, 2 non-vertical lines are parallel if and only if they have the same slope. Any 2 vertical lines are parallel. Then we have the perpendicular lines theorem. This theorem states, in a coordinate plane, 2 non-vertical lines are perpendicular if and only if the product of their slopes is negative 1. Vertical and horizontal lines are perpendicular. Note, if a line has a slope of a over b, then the slope of a perpendicular line is negative b over a. The ratio a over b and negative b over a are called opposite reciprocals. So now we are going to learn how to determine whether lines are parallel, perpendicular, or neither. First, we're going to graph each pair of lines, which I've already done for you, and then use slopes to determine whether the lines are parallel, perpendicular, or neither. So since I've already graphed the points, we're just going to do the slope formula part. So we're going to plug in x, y, and zw for our first one. So x, y is going to equal negative 2 minus 5 over 6 minus a negative 2. This is going to give us negative 7 over 8. Now we're going to plug in ZW to our slope formula. This is going to equal 0 minus 6 over 4 minus negative 3. This is going to equal negative 6 over 7. So since these two equations don't equal each other, or their product isn't negative 1, this means that these are neither perpendicular or parallel. Now we will move on to number 2. So, for number 2, we're going to start with line AB. Line AB is going to equal negative 1 minus 2 over 2 minus 7. And this is going to give us negative 3 over negative 5. And negative 3 over negative 5 is going to equal 3 over 5. Then we're going to graph line CD, not graph. We're going to plug this into the slope formula. And this is going to equal negative 3 minus a negative 6 over 2 minus a negative 3. This is going to equal 3 over 5. So, since these two equations are equal to each other, this means that these two lines are parallel. And this is shown on the graph as well. Last, we're going to do the slope formula for lines JK and JL. So, first we do line JK. Line JK is equal to negative 2 minus a negative 2 over a negative 4 minus 4. This will give us 0 over negative 8, which is going to equal 0. Then we do line JL. When you plug this into slope formula, it equals negative 2 minus 6 over negative 4 minus a negative 4. This is going to equal negative 8 over 0. These two lines are line JL is undefined. So, these two lines are perpendicular. So now you know how to find the slope of the line and how to use slopes to identify parallel and perpendicular lines.
Lesson 3-6. Point slope form of a line is y minus y equals m times x minus x, where m is the slope and x1 and y1 is a given point on the line. An example would be y minus 3 equals 2 times x minus 4. The measurement m equals 2 by x1 and y1 equals 4 and 3. The slope-intercept form of a line is y equals mx plus b, where m is the slope and b is the y-intercept. Y equals 3x plus 6, so m equals 3 and b equals 6. The equation of a vertical line is x equals a, where a is the x-intercept, x equals 5. The equation of a horizontal line is y equals b, where b is the y-intercept, so y equals 2. Writing the equations of lines. Example A is point slope. Y minus y equals m times x minus x. Y minus 1 equals 3 times x minus 2. This is point slope. Example B is slope-intercept form. M equals 2 minus 4 over negative 1 minus 0, which equals negative 2 over negative 1, which equals 2. Y equals mx plus b. 4 equals 2 times 0 plus b. 4 equals b, so y equals 2x plus 4. Equals 2x plus 4. Example C, x and y in point slope. M equals 3 minus 0 over 0 minus 2, which equals negative 3 over 2. Y minus y1 equals m times x minus x1, so y minus 0 equals 3 over 2 times x minus 2. Graphing. Example A. We see that y equals 3 over 2x plus 3. We need to remember rise over run, so we go to 0, 3, rise 3, and run 2. Here are some line pairs. Parallel lines, intersecting lines, and coinciding lines. Parallel lines. An example would be y equals 5x plus 8 and y equals 5x minus 4. They have the same slope but a different y-intercept. Intersecting lines. An example would be y equals 2x minus 5 and y equals 4x plus 3. We can see that they are intersecting lines because they have different slopes. Coinciding lines. An example would be y equals 2x minus 4 and y equals 2x minus 4. They have the same slope and the same y-intercept. Here are some practice problems. Y equals 3x minus 5 and y equals negative 3x plus 1. We have to put it as y equals 3x minus 5 and the measurement and m equals 3. Y equals negative 3x plus 1 and m2 equals negative 3. m1 and m2 equals 3 times 3x, which equals 3 times negative 3x, which equals negative 9. In number 2, we see that we have 2 and 5 and 4 and 9. The measure m equal m times 2 plus 4 over 2 and 5 plus 9 over 2 goes down to m and 3 and 7. m1 equals 9 minus 5 over 4 minus 2. m1 equals 2. So m1 and m2 equal negative 1. So 2m2 equals negative 1. So y minus 7 equals 1/2 and x minus 3. Going down, we see that y minus 7 equals negative 1/2 x plus 3 over 2. Y equals negative 1/2 x plus 17 over 2. And our last step would be that y equals negative 1/2 x plus 17 over 2.